Bienvenidos a todos, bienvenidas a todas en una edición más de JConf 2025. Vamos a presentar a Mihaela. Mihaela es arquitecta de software en Systematic en Rumanía. Es doctora también en algoritmos de redes neuronales artificiales. Es profesora adjunta de la Universidad de Cibernética e Informática de Bucarest. Ella viene muchos años trabajando en el dominio de telecomunicaciones y defensa, especialmente enfocando su carrera en lenguajes de programación como Java, Spring Boot, C o C Sharp, Scala, etc. Welcome, Mihaela, to JConf Peru Edition 2024. How are you doing?
Thank you. Hello, hola. Hola to todo el mundo. My Spanish is not that good. I just know a few words. I'm really happy to be here. And shall we start? Are we ready?
Oh, we're ready. So, ready? The stage is yours.
Okay, thank you. So, hello everyone. I'm Mihaela. I'm a software architect at Systematic, which is a Danish company specialized in building software for critical domains such as defense, which represents the business unit for which I'm currently working. But we also have other domains such as healthcare, libraries and learning, intelligence and national security, and many more. I'm also a teacher at the Faculty of Cybernetics and Informatics in Bucharest, in Romania. But today I'm going to share one of our most recent experiences that we had in the process of moving away from Java 8. So I'm going to share with you our journey in moving away from this old version. And at the time we started this migration, the latest long-term support version was Java 17. So this was our target. In the meantime, another one appeared while we managed to finish our process. So let me share a bit of insight about our upcoming journey, our Java journey. And first of all, let me walk you through our journey that we went over a couple of releases actually, as it wasn't an easy task, especially as we weren't allowed to use any third-party or open source software, such as Rewrite, for example, that could have eased our migration process. In defense, unfortunately, we can only use some special third-party license applications or to build our own solutions. So for this, I would like to provide a very brief overview of what we are currently doing in our project, or more precisely, how our application is structured from an architectural point of view, and for whom we are actually developing, so that you can understand the complexity of this task for us. Also, I will share some of the main reasons that were behind the decision of migrating to a newer Java version. Also, what challenges did we face during the entire process and how we managed to overcome each of them. And at the end, to share some insights on what's next in terms of our Java journey. Obviously, at the end, we will have some more question and answers. So, I did mention at the beginning that I work for the defense domain, which means that we are building software for them, for those that you can see now in these pictures on the slide. Those that are performing their task either on land, on air, on sea, or from a command and control centralized server. So it was highly important that we don't break even the smallest functionality that they are using just for our Java migration task. But let's move away from the domain and look from a technical perspective at what we currently have. And if I am to resume our overall architecture to just a few boxes, then I would describe it as follows. We have a very big Java 8 monolith application, which is also on its own journey of being modularized, but that's another story, still in progress though. And besides this monolith, we also have a very large number of Java 8 plugins, either developed by us directly or by our customers as integrators by using our APIs, or they are simply made by other teams in Systematic that have their own applications and they deploy them on top of ours. So all of them needed to be migrated as well. And lastly, because obviously that's not enough, we have a couple of microservices that we built from scratch for the newer functionalities that we had to implement, or they were migrated from that very big monolith that I told you about. And just looking at these simplified boxes, there seems to be a lot to migrate. I can only guess that for most of you, this seems familiar, and most likely you're in similar situations or have been in a recent situation recently. All right, so let's continue a bit with a very important question that arose at that moment when we added on our journey the migration to a newer Java version. Why? Why do we need to invest time and effort to migrate to a newer Java version? We all know that expression. If it works, well, don't break it. We managed to make a list of reasons, a list that, after all, decided that we really needed to start on this journey. So, first of all, we wanted to improve our way of working, our way of developing. Any developer wants to benefit from the newest language enhancements, those that will help write clearer code, that will help reduce code errors, that will simplify the entire code workflow. More than this, we wanted to benefit from all the newer security fixes that resolve different security vulnerabilities or that will contribute to improving even more our application integrity and data protection. Also, we wanted to benefit from all the newer enhancements in terms of APIs and libraries that appeared in recent Java versions. The list definitely continues with some performance improvements that we wanted to benefit from, because the newer Java versions are bringing a lot of performance improvements that could help increase our application responsiveness, or in other words, to make it faster and better. And lastly, well, it's last only on my list here, but it was really important, and actually it decided the version to which to start the upgrade process. Because we wanted, and actually we needed, the ability to update other infrastructure components. And I will start with this one and provide a few more details about it. So, first of all, I mentioned that it was important to take a decision, and this is because in our environment, we are using Wildfly as our application server. And because we are using a very old version and we wanted to update, we started to look at Wildfly 29. Well, this is no longer compatible with Java 8, and it requires at least Java 11. So at this point, we could have made a smaller upgrade process from Java 8 to Java 11. But we continued to look, and we started to investigate how about trying to use a newer Spring version. And we started to look at Spring Boot 3 or Spring Framework 6, which also doesn't work with Java 8, what we had, and not even with 11, which could have been a potential target version for our migration process. But this one requires at least Java 17. Therefore, just by looking at these two, at Wildfly and Spring, the decision was quite simple. We needed a way to get to Java 17. But before Java 8 and Java 17, there are almost 10 releases. So another question appeared at this moment. What changed between them, and what can actually bring value to us? Because we didn't want to start a process just to have a newer version. Something had to be important for us in those release notes that were in between these versions, so that it can be beneficial for us. And I will list a couple of these benefits that we considered helpful, but please take into account that this is just a simplified list. There are plenty more from where this list came from. And I will start now with something that we considered useful for us, and that's the multi-release jar functionality. This was introduced not that far away from Java 8. It appeared in Java 9, and it allows the possibility of a class to be completely replaced at runtime. So this means that we can simultaneously have multiple implementations of the same class, but compatible with different JDK versions. And let's assume that we have two classes, like I have here in my example. We have class A and class B, as illustrated here, both written in Java 8, therefore with a slower API. Let's make this assumption. In Java 17, we assume that we have some new APIs, some new features that can improve our overall performance when it comes to these two classes. But due to some integrations, we cannot replace those Java 8 implementations directly with the new ones from Java 17. So we needed a solution to have both of them and to be able to switch between them if needed. And this is now possible with the multi-release jar feature because we can add the implementation of Java 17 classes. As you can see here in this directory in a meta-inf versions 17, just place the new implementation for A and B, and that's it. Afterwards, the class loading mechanism will know at runtime which Java version we are using, and it will load that class for us, either from the old Java 8 version or from the new Java 17. So we consider this to be quite handy, especially due to our integrators, which were not all of them in the position of also performing this upgrade along with us. Let's see another benefit. And moving forward, we have quite a lot of improvements that were made for switch expressions. And honestly, we have plenty of them in our application. And let's take a simple example, and let's look at the one that I have illustrated here on the slide. We want to extract the quarter based on the month number that we are providing as argument, and because there are 12 months, we obviously have 12 case expressions, plus a default condition for the situation in which we are providing an invalid number. If we were to have some logic, some special conditions of handling each of them, and some of them may repeat, for example, if it's month 1 and 3 do the same specific operations, then we could end up with a lot of duplicate code, and it pretty for sure. But this is the old way with Java 8. In newer Java versions, the case expressions can now contain multiple values. And we can already see on this slide how we can simplify those 12 case expressions and just group them into 4. And it already looks quite better than what Java 8 had to offer. And there's more. We can now use the yield identifier to still return that value for the switch and also to be able to execute additional operations within a code block. And even more, now switch can be used with enums. And if let's take an example, the one that I have illustrated here. If we have an enum for our month, which means that we have a complete list of values and we need to handle all of them, we no longer have to handle that default operator. It is still added in the bytecode, but we are no longer required to manually add it in here in our switch expression. So there were a lot of improvements that can simplify our way of just writing a simple switch expression within that JP 361. And a couple of them we can already see on this slide. But let's take other examples. And I could say that there were plenty of enhancements made for instance of operator. And they were added as a feature called pattern matching for instance of as part of several JP. I think that each of us has at least once written or at least seen in the application validation using instance of, where we simply test if an object is an instance of a specific class, like I have here in my example with circle and rectangle, in which case we need a variable of that type. Afterwards, we need to cast it to that class type, and only afterwards we are able to apply the operation we actually need. But again, this is the old way of handling the instance of cases. Now we can have a simplified process because the instance of operator has been enhanced enough to both test that the parameter is an instance of our class and at the same time to be able to assign it to a binding variable that can be used directly in the context of that switch to apply any required operations. And we can already see how this looks like in my example here. So we no longer have to write that much code as previously did in Java 8 and previous versions. Now let's move away from the last two and actually combine them instead of just looking at them individually. And this means that we have something called pattern matching for switch. And let's take another example with the instance of operator. And this time we want to test based on a collection object if it is an object of a stack, if it is an object of a linked list, or it is an object of a vector. And in the old way, you already know the drill, and it is illustrated here on this slide. We need an object of that type, we need to cast it, and then apply the operation that we need. But with the enhancements made, we now have the flexibility of defining something called types for the switch expressions. And by using this type pattern, as it is being called, we can now use directly within the switch that class for which we want to test against and have that variable already defined in there and just be able to apply the operation. And you can already see this on the slide. But there is more. If um, if we want to combine that instance of validation, for example, with another Boolean validation, let's assume that we want to perform some actions only if that size is greater than 5 for a linked list, for example, we have something called guarded patterns. And you can see here the second example, that case with linked list and combination with a Boolean validation for the size greater than 5. And there is another example now, the last one, for this pattern matching for switch. We can now add and group a lot more validation in something called parentheses pattern. So we can simply group any number of conditions based on what we need to test against, but just by using some parentheses. And we considered all of them quite handy because the application, our code, is full of this sort of pattern matching for switch. But let's move away from all of this because there are plenty more benefits that we found, and we considered text blocks quite useful. These are used for multi-line text like licenses, but also for HTML and SQL codes, and I guess we all have them in our projects, at least we do. We have plenty of HTML sequences and a lot of SQL native queries. And now let's look a bit on how an example from Java 8 looks like. So we have the regular escape sequences, codes, and the plus operator at the beginning and at the end of each line. In comparison, below, you can see how an example now looks with a newer Java version, and this was actually introduced in Java 15. So instead of older boilerplate operators, we now just have 3 codes at the beginning and 3 codes at the end. And what is inside them really looks like an HTML code. So it's less risky to introduce some problems with it because, for example, we forgot a code or we forgot a plus operator or something similar. But let's take a look at another example, and this time for an SQL code. The first one, old one, it's full with some escape sequences and other operators similar to the previous one that we saw, but this wasn't that easy to test directly in an SQL editor, for example. While the second example with text blocks addition in newer Java, well, we just have 3 codes at the beginning and at the end, and the native query from inside can simply be copy-pasted in an SQL editor we can ensure that it works correctly, it returns what is needed, and so on. And the list will definitely continue with new benefits now. And let's see some other examples that were introduced. And first up, we now have some new APIs for Stream. And as an example that I have illustrated here, we can use a toList option now that can be applied directly on the stream. So this means that instead of relying on the collector.toStream, we can now use directly toList, and it is way easier to transform a stream into a list, and the result is indeed unmodifiable. But there are several other additions to other APIs, and another look we can have at string. We have now an indent method that can be used to either add or to remove indentation from the beginning of the line for a string. And I have a couple examples here. They obviously count for the length of that string, but at least to display it in a specific manner, this is very useful. Besides indentation, we also have transform. And this new method that was added in the API can be used to call a function on a given string. And I have here an example for a concatenation, but another one that I can think of at this moment would be to apply camel conversion from the string utils by using this transfer method. That can be very handy as well. Let's look now at another API that was enhanced, and that is represented by the arrays. And I stopped at this because we had a couple of workarounds to just determine the first mismatch between two arrays. And now the API contains a simple mismatch method that can simply return the first mismatch between those two arrays given as arguments, instead of looping through each of them and see which is the first position where the characters doesn't match, as we used to have previously. Also, a different new functionality that was added, and we consider this quite handy because our developers are full stack and most of them are familiar with other programming languages and the use of var. So in newer Java versions, this was also added, something like local variable type inference, how the feature was called. And we can now start using var like in other programming languages, as I mentioned. So instead of having a string, we can use a var, and the compiler will infer the type of that variable using the value that is actually being assigned. But let's move to something hopefully even more interesting than what we saw, but I do hope that you find all of them interesting. But at least for us, this was something quite important because we wanted to start using right away. And let's take a look directly at the code. So in this example, we have something like public, record, min max, int min, int max, and some bracelet. Well, just by having this line defined in our applications, you will have the getters, you will have the constructor, you get the hash code, equals, and toString methods. So all the boilerplate code that you would have either written manually or most probably have the IDE generating them for you. We can also extend that besides what is being generated automatically, we still can define a lot of other methods that can bring additional values. And as example, we can have something called a compact constructor. And in my example here, we check if, for example, the min is greater than max, in which case we throw a specific exception. Or maybe we can add some additional methods to do some calculation. And I have here two examples, one to calculate the arithmetic average and the other one to calculate the geometric average. And the list can continue, we can add additional more methods. But I'm still discussing about records, but I haven't explicitly defined what they are. So they are immutable, they are final, they can be considered as data holder classes or tuples with a type. and they are very useful for DTOs and to return multiple values at once, but obviously not for the GPA entities because those still are mutable. So for all our immutable classes, and we have plenty of them, this could simplify our way of writing them. And let's take another example of something quite useful, and that is given by the possibility of having sealed classes and interfaces. And let's look at some code pieces, some snippets that I have added here. First of all, we have public sealed class, um, device, permits, computer, and mobile. This means that the device class can only have two types of implementations. It can be either a computer or a mobile. So, by having such a definition, we are now closing the class hierarchy, and those computer and mobile classes can be on their own, either final, meaning that no other class can extend them. They can be also sealed, and we can also do the same and define some implementations, a list of implementations for them, similar like we have done for device, or they can be non-sealed, meaning that they can be public, available for everyone to extend and use them. Therefore, the sealed classes, and the same applies to interfaces. I haven't added examples for interfaces, but they work exactly the same. They provide a fine-grained inheritance control for our application, and we consider them quite handy. But I have listed a lot of benefits so far, represented by newer functionalities or enhancements to the existing ones, enhancements to the APIs. And as mentioned, the list can definitely continue. These are just a few of the examples that made an argument for us to start the process of migrating that very huge monolith with all the plugins and all the microservices. And they all sounded great. And I think that everyone wants to work with them, plus everything else. I will repeat that I haven't listed, but they do exist, and they are coming with newer Java versions. But what's the catch here? Could we just specify in our application in Gradle or what we are each using in our applications that now we start using Java 17 and that's it? We get all these new shiny features with no issues? Unfortunately, the short answer is no. And I have to say that there were quite a lot of challenges that appeared for us, a lot of challenges during that upgrade process that made us even delay with one release this migration. So we had to move a lot of changes that we did from one branch to another and simply delayed because we didn't manage to finish everything and a lot didn't work. A lot of features stopped working. And this is because in newer Java versions, we also have missing libraries. We also have APIs that were simply removed. There were several out-of-date dependencies and a lot of deprecations, and we had to deal with all of them. We had to address everything so that everything to work at least how they used to be. But in our first iteration, things stopped working. Our application didn't start, our tests were failing, so we had quite a lot of problems. There might have been a lot of newer functionalities and we wanted to benefit from all of them, but firstly, we had to ensure that everything works. And those things that were removed, we had to find way of replacing them. And let me try to do a drawing here to visualize the migration process in a simplified way. So let's assume that our Java 8 application depended only on 4 libraries. Obviously, there were more, but I only draw 4 boxes of here. So let's assume that there are only 4 direct dependencies. But in reality, there are not only 4 dependencies. And that's because these 4 dependencies have their own dependencies. And based on the number of boxes that I draw here, we actually have 27. So 27 dependencies, and they all needed to be upgraded. And this is just a drawing with 27. But in reality, we have hundreds of dependencies because we had quite a lot of functionalities with a lot of dependencies. So all of them needed to be upgraded. And let's assume that most of them are in general ready to be upgraded. And this happened for us. Almost all of them were ready to be upgraded with no issues. But the reality says that it only takes one that cannot be updated to block the entire process. And this is what happened for us. It only takes one thing that no longer exists in Java 17 or to the target version that you want to update to. It can be something vital for your application, or it can be something that you are not even aware of having it in the application. Some sort of things may happen when you start on a journey like this. And based on this analogy, let me tell you exactly what happened for us, what we experienced. Um, our migration was sort of blocked because we were using Nashorn in our application, and Nashorn was removed starting with Java 15. Well, they did announce deprecation in Java 11, but we were at Java 8. We didn't have on the roadmap to start the Java migration process, so we simply ignored that announcement. So we continued to build by using Nashorn continuously and make our application, our functionality using this even bigger and bigger. And Nashorn was actually being used for an important feature by our customer, commonly used and represented by a collaborative text document. Imagine that it is like a Google Docs embedded into our application. And it allows collaborative editing. So a lot of military guys staying at the same time on the same document, making changes, inserting images, links to map coordinates, and a lot of other things, and see each other changes in real time. And we use Nashorn for this. And the reason that it was removed in Java 15 is because this is based on the implementation of ECMAScript, and all the other changes that were made in your Java version made it even harder to be maintained. So they decided to remove it. Well, luckily for us, there were alternatives, and we started to investigate all of them. For example, there is GraalVM, and we took this into consideration. But on the other hand, based on the complexity it would have introduced in our application and the possibility, at least this is how we consider it, that at some point in one day, maybe we will get into the same situation in the future, like it happened with Nashorn, to be removed from the JDK or something similar or replaced by something, we decided not to use it. So we ended up actually building an in-house solution and had those algorithms represented both on the client and on the backend side. So we removed the dependency to a JavaScript engine that could have made the translation in Java for us. Another approach, and I mentioned it here because it may be useful for something, would have been to continue to use Nashorn because it was removed from the JDK, but it was moved to OpenJDK. But we couldn't use it because of some license issues. I did mention at the beginning that in the military software that we are building, we are quite strict from this point of view. So Nashorn from OpenJDK was not an option for us. But maybe for some other projects, this could be an alternative as well. And this was only the first challenge, and we spent some time redoing all those algorithms and retesting everything to ensure that everything still works accurate. This was a big task on its own in the migration process. And another problem that I would like to share with you is in regards to Lombok. And that is because due to JP 396, that introduced strong encapsulation that comes with the JDK internals, Lombok can no longer get the JDK internals. And therefore, we were getting a lot of cannot access different class error messages, like the one from this example here on the slide. Um, there were workarounds that could have been made in the code, but this happened in a lot of places. So the simple solution for us was to simply update Lombok to a version that had the necessary fixes for this. But yet another task that we had to handle, another migration. Afterwards, something similar happened with Mockito, but here the problems were even bigger. And it was obviously our fault because we were using quite a very old version. So in order to be able to use Java 17, we had to update it. And this proved to be on its own an extremely big task that involved a lot of changes because, well, half of our unit tests just failed after we performed the migration. And that's because there were quite a lot of changes for the new versions. Uh, and I will try to list here a couple of them that you can see now on the slide. So there were a lot of changes. We had different methods that were replaced completely. There were types that were changed, and another situation that I found funny when I saw it in the code, because we sort of used it in that wrong way. The any int matcher was so flexible in the old days that it could have been used to test for other data types such as long, and it works. It worked. Sorry, but obviously after the migration, this was no longer the case. But anyway, these are just a couple of examples, and we spent weeks figuring out why our tests were failing, and to actually rewrite them and make sure everything still works accurate. And moving forward, there were some other challenges in regards to some Java EE modules that were removed as well from the JDK. But luckily, this was a smaller task than we initially considered it. It was an effort, obviously, for the migration process, but it was easy to replace the Java EE modules from the JDK to those from Jakarta because they were moved there. So this was a smaller task in comparison to the unit test, for example, but it was an additional effort that we didn't consider it at the beginning. And I also want to mention about some deprecations, and that's because we consider that we need to keep an eye on what is announced as being deprecated or even marked to be removed in future versions so that we can address them on time before we get in the similar situation with the one that we had with Nashor. So this time we wanted to be more careful. And among the examples, we have the new instance that is replaced to the one from the get declare constructor. We have the constructor of the primitive wrappers. So instead of new integer, for example, we need to use integer value of. And the same for the local constructor, and the list can definitely continue. And these three were just some examples from our code. But as mentioned, we had to consider them and ensure they won't break something in the future or be something as big as the nation for us. And I think that this concludes some of the top challenges that we had with the migration, and some of them especially as the removal of nation and those unit tests, as mentioned, they delayed our delivery and we had to postpone it to the next release. But at the end, it is important that we managed to benefit from a lot of newer functionalities, enhancements, APIs, and I already listed some of them. But for us, this doesn't end here, because after we finally managed to finish everything, we started looking at what to put next on our roadmap in terms of Java migration. And we started to look at the newer Java versions that were released. And that's because, as I mentioned, when we started, the latest one was 17. But until we managed to finish it, 21 already appeared. And we can look already that 25 is next year. So we are in between deciding exactly to which version to get, but most likely it will be either 21 or 25 for us. And we also looked a bit at what we already have. So up until this moment, from the versions that are currently out there, and see what they offer so that we can look for potential benefits, but also issues, because we are very careful about them today. And the summary of what they offer is representing by this long list. Let me load all of them and we can walk through each of them. So starting with Java 21, or in between 21 and 23, that was released recently, we have virtual threads, we have sequence collections, we have record patterns, we have a couple of new functionalities still in preview mode, but until 25 probably they won't be in preview mode anymore, such as scoped values, string templates, unnamed variables. There are several enhancements made through Vector API, for example. We have some new stream gatherers, and also something called foreign function and memory API, which actually allows Java to interoperate with native query and memory outside the JVM. And this is quite crucial, a crucial part of a long-term goal that they announced to replace the Java native interface with a safer and more flexible API. So all of this sounds quite amazing for us, and we look forward to get into the position of being able to test them in our environments, and afterwards to use them in our production application and to be beneficial from all our customers. And I forgot to load the library and performance improvements, because there are a lot of performance improvements, new garbage collectors, and a lot of enhancements that can improve the overall performance of our applications. And to sum up everything that I have talked to you about, I would say that moving away from Java 8 is a significant step that requires time and careful planning, but I would say that long-term benefits make it well worth the effort. At least for us, it did. Java 8 is no longer maintained, it's very old, which brings security and stability risks. Newer Java versions such as 17, 21, and any upcoming one, on the other hand, which are long-term support versions, ensures ongoing updates and support. So you will also experience substantial performance improvements, and to be able to take advantage of powerful new features such as modern APIs, and we looked at a couple of them already, enhanced language syntax, we've seen a lot of examples, and some better tools for development. So by upgrading, we are not only future-proof our applications, but we also optimize them from a performance and a productivity for all our development teams. So this migration is not just a necessary update, it's an opportunity to elevate our projects and get them to the next level. And I think that will be all from my side. And let's see if we have some questions.
For sure, Mihaela. Thank you. Definitely good advice for all of us who have gone through a migration process. Uh, we have a few questions here.
Okay.
Gonna start with the first one. Frank Ayala asked you how you see classes compared to enums in terms of restricting a type's possible values. Could enum have been used in a similar scenario?
Well, self classes is about more of inheritance control between classes.
Mm,
I guess that in some specific scenarios we could use enums so that they can do the trick for them. But
mm,
I would suggest giving a try to seal classes and see the benefits of it. You can define exactly which other classes can be represented as implementation for that sealed class, and you can avoid having a lot of classes making use of your own class that you don't want to be extended by everyone. But
Mm.
definitely enums in some scenarios can be used for this.
Right, right. This is another question related to the previous one. Say that the seed classes could be impacted the performance around time.
How do
How
sealed classes impact performance at runtime, especially with regards to pattern matching? Um, I'm not sure if they impact performance at runtime. At least from our tests so far, we didn't observe performance issues, especially when it comes to pattern matching. But we only tested with our own scenario. So maybe if it is a different scenario, some different classes, some different pattern matching that are heavier, I guess, in terms of syntax and so on, maybe it could impact performance, but not for us. It didn't happen. So when we did some performance tests, things improved. We didn't face the issues. But I can't say for sure that in certain situations this may not happen.
mm, all right. Here another question from Oscar Dario Flores. He said, "Did you use any tool to do the migration process automatically, or everything was manually in your experience?"
Yeah, unfortunately, we had to do the migration manually. We did look at that open rewrite tool and we wanted to use it, at least in some local tests that we perform on our own projects. Everything worked fine and it could have been very useful for our defense project. But unfortunately, due to the restriction of the application of the domain, we weren't allowed. So most of the things were done,
Mm,
and I think some of them were some rewrite of some unit tests and stuff like this were made some by some scripts, but those were internal and made by us. So everything was done in house.
all right, got it, got it. Um, Another question from Roberto Tarazona said, was GDIPS, GDK Dependency Analyzer, or a similar tool used to identify what was the deprecated APIs or features?
Yeah, we had tested the JDK dependency analyzer. That was useful for us. We haven't tried something else, but I'm sure there are plenty of more tools, similar tools to identify deprecated APIs. But first of all, we just looked at the descriptions for each feature and identified. But afterwards, yeah, we used the JDEPs.
All right. Here's another interesting question. Do you recommend it to wait and migrate from LTS version to LTS, or we can to migrate to new versions?
Um, yeah, that's an interesting question. If we should migrate to LTS or to a new Java version once it is
Mm,
available. At least on the project I work so far, we were always with the assumption and the recommendation and forced sort of to use the long-term support version as that has official support and so on, while the others are maybe in preview mode or things may change and stuff like this. So
yeah.
from my project, at least that I'm currently working on, we have to wait for a long-term support version.
Right, right. Sure, sure. The last question for Alexander said, what challenges have you had in the migration visa? What strategy and best practices do you recommend for this type of migration, Java migration process?
Okay, what challenges did we had when we started the migration? The as
Yeah, the
I
top
always
challenges you have.
the top challenges. The first one was with Nashville.
Mm,
Because that was removed, that was heavily used in our application, and that was a difficult task because we had to replace it with something. And the alternatives like GraalVM would have had a big impact in our project because it is a very strong application, heavy to use in our project. So we had to sort of rewrite the algorithms. And for collaborative text editor, that's a big and difficult task. That was the first challenge. And the second, if I were to resume to just two big challenges, the second one was with the Mockito unit test, because after we finished the migration, a lot of tests were just failing. So we had to take each of them and rewrite them, see what changed, and see how to address each change to make our unit test work, at least same as before.
Sure. All right. So this is all questions we had for you. Thank you so much, Mihaela, to join us.
Thank you as well.
We wait for you for the next JConf to the next year, probably, if you can.
Looking forward for it. Muchas gracias. Thank you and
Thank you
have
so
a good
much.
day ahead.
Have, have a good day. Bye bye.
Bye bye.